Okay, everyone, my name is Hany Fahim. I'm the founder and CEO of VM Farms Inc. VM Farms is a fully managed, scalable web hosting provider. We're cloud-based. We're right here in Toronto. Our servers are also Canadian-based as well. In one sentence, our job is to keep websites online. That's essentially what we do. We work on the ops side of things, so as we talk in the title. We're actually starting a series of talks called Tales from the Ops Side. So our entire company is basically, our view is to manage the operations for our clients, and we work well with developers. So we're going to start to talk about all the fun stuff that we do at VM Farms and all the challenges that we deal with scaling large websites. So today I'm going to be telling a story about one particular client of ours that came to us from another provider that they're e-commerce based and they're trying to take on Black Friday. The subtitle there is AKA Scaling Magento. How many people here know what Magento is? All right, some of you. Magento is basically an e-commerce platform. It's written in PHP. It's very popular. It has both enterprise and community support in there, so you can pay for it if you want, although I don't recommend it. So basically, the challenge that was presented to us is that this customer had a really big e-commerce site, and they have very, very sticky customers. And what I mean by sticky customers is that they get repeat customers all the time. So anytime they send out a notification or newsletters or something like that, they pretty much get all their clients back. So they had a very sticky customer base there. Every single Black Friday, they would go down because they could not handle the load that it would bring on. They tried everything from staggering, the newsletters to make sure that they can deal with them in chunks. No matter what they did, they kept going down over and over. So they came to us with this problem of how do we stay up for Black Friday, because it was projected to be the biggest one of the year of their existence. So they came to us and asked us to help with this. The problem is Magento is not easily scalable at all. So our goal was to get it to scale and make sure that there was no downtime whatsoever. So taking a look at this, there's kind of three ways that you can scale Magento that we saw at least. The first one is scaling up, and that's called upgrading. Essentially just kind of upgrade until you can't upgrade anymore. The second way is called scaling out. And scaling out is basically adding more servers to the farm. And there's many ways of approaching that. It's called horizontal scaling. And the third way is scaling out, but doing it the hard way. So I'm just going to go quickly over each one. So you're basically turning it up to 11 when you're scaling up. You basically add more CPU, more memory, more disk, everything that you got, you throw at it. There's not many options with this though, because eventually you're going to hit the limits of what a single server can do. This client actually already did that, and they came from the previous provider with the biggest server that they could offer. They threw every single piece of RAM that they could find in the data center. They surpassed this by far. So the second option is scaling out, and I call that scaling out the easy way. The first step when you're scaling out is you basically turn on all the caches. The very first thing you do is you turn on the cache. Anything that says the word cache in the interface, you turn that on. Anything that says it, you just, everything. For example, Magento works well with Redis. So you basically, you turn on Redis. You install Redis and you turn it on. And it actually has support for storing sessions in Redis, and it also has support for full page cache, which is a beautiful feature of Magento. It takes the entire page, renders it all, and stuffs it into Redis. So it's really fast. Many plugins also use memcache, so anytime it says use memcache, you check that box, click save, you give it the IP, turn it all on. The last thing is Amazon's CDN. So of course, like any big site, if you don't have a CDN, you have to do that. It's a cheap way of scaling, a very low cost, and it gives you huge performance gain, especially if your customers are around the globe. So turn that on. Magento has great support for CDN, so you definitely turn that on. Step two is you split up the services. So as I mentioned, there's the database, there's Redis, there's memcache. You take all those components, anything that kind of operates on the network, you put them on their own servers. You take them off. So you stick Redis, memcache, the database, everything. You split it up that way. Our client had already done this as well. So not only did they turn everything to 11, they already split up all the services. So they already hit this and they already reached the limit, and it wasn't going to work out that way. So this is the point when they came to us. So we tried going through those steps. We're like, nope, we already did that. So the third step is you add more servers and load balance. Very, very simple. Magento is a beast, and that's putting it mildly. It is a really big consumer of resources, needs a lot of CPU, needs a lot of memory, especially as you start adding on plugins. That thing can really, it can get very, very big, so you have to scale out this cluster over here. So really simple. We thought, yeah, just stick a load balancer in front of it and problem solved. That should be easy. There's a wrinkle though. So remember how I said turn on all the caches. One of the caches is a image-based cache. So Magento has a built-in image cache, and it actually works very well. There's a problem with it though. When a user hits a page, it immediately starts writing out the cache to the local disk and then serves it up to the client. The problem with this is it goes to the database and tells the database, hey, I created a cached image for this particular image over here, and here's the location. So the next time when a client comes in to hit it, another user, it'll check the database first, and the database will tell, yeah, that's already generated, here's the URL, and it serves it up to the client. When you're load balanced though, if you're coming in on, let's say, server A, and the next client comes on server B and it checks the database, it's like, yeah, it's at this location over here, it's not going to be there. So you're going to get a big fat 404. And this is a problem. It was built in deep into Magento's core, so it's not easily changeable. This is what I call the lack of cluster awareness. Cluster awareness is basically knowing the existence of other servers in the cluster. You don't necessarily have to know it, but it should be architected in a way where you don't need to be limited to a single server, and unfortunately Magento doesn't do this. So we had a little bit of a problem on our hands. We looked online and said, what do other people do? Obviously Magento is very popular. What do other people do? Time and time again, this was the solution. Well, stick a shared storage on there. Use NFS, put all your image cache on there, and everyone is happy. You know, you can scale to as many servers as you want. In my experience as an ops person, and especially the many people from my own company, we come from companies that use shared storage religiously, and they're no good, because what happens when they fail? Lots of problems happen, and those things fail. Shared storage, no matter what you do, is going to fail, and it's going to fail big time. Any kind of failure is usually catastrophic. It takes everything down. So it's not a really good design pattern. The whole goal was to scale this application. We don't want any single points of failure in this environment over here to take them down, especially on their big day. And usually recoveries take a very long time. If something crashes, file systems are corrupted. It's a terrible situation. So what do we do here? We have a bunch of servers. We want to scale out. How do we get them to see the same view of the image cache? So if it's not going to be shared storage, the other option is to use replication. You basically copy the data around the cluster. Make sure that everyone can get access to all the same data in there. Obviously, you want to avoid this craziness over here where basically every server syncs to every other one in the cluster, because as you add more servers, the number of connections grows exponentially. So, you know, this thing can cause a lot of network traffic to you know, take out the entire cluster that way. So you want to avoid this. So we thought long and hard and took a look at some different types of architectures. We came up with something called the ring sync. Basically, every server is responsible for shipping its data to its neighbor in one direction, and it goes around in a little circle. We found a little piece of technology called lsyncd. Who here has heard of lsyncd? It's actually fantastic. If you haven't, you should use it. It's fantastic. It's a really lightweight program. It uses the Linux kernel's iNotify utility. iNotify is basically a way for the kernel to tell you, hey, some event happened on the file system, like you change a file. It can notify you to say, hey, this has changed. So this worked beautifully because lsyncd uses rsync, gets iNotify events, and then triggers some syncing events. So you don't have to do something like setting up cron jobs where they're basically syncing on a regular basis. You can use this facility to only sync when you need to sync. So this worked well. This sounded fantastic out of the box, but obviously there's a big gaping hole in here where a single server fails and the entire ring comes down. So the nice thing about lsyncd is it has some programmable logic in it. Using Lua, you can actually sit there and program any kind of sync logic you want. So what we did is we added some simple logic to say, hey, this node fails, you skip over that and go to the next guy. And it works well because when it comes back online, rsync will always pick up whatever changes are missing, and it'll pick up anything that it's missed when it dropped out of the cluster. So it's a really, really nice solution that way. So that's all nice and dandy, but there's a problem here as well. Because it's a ring sync, there's a delay. So if you take a look at one of the servers in the cluster there, the guy sitting right behind you is going to be the last one to pick up any change that go in the cluster. And you can kind of tweak the speed, so you can say go a little bit faster or as fast as you want, but there's always going to be a delay. So what happens is when a user hits it, you have to make sure that they're always stuck to the same system. So using the load balancer, you can turn on session affinity or sticky sessions and basically tell a single user that you're always going to be stuck to this server as long as it stays up and running. So if you generate an image cache on that one server, as it's syncing around the cluster, any subsequent requests from that user is going to hit the same server every single time. So we thought that's fantastic. Okay, so we got rid of the centralized storage. We figured out the way that to eliminate any kind of sync delay. So you can make this cluster as big as you want, and the delay will have no impact on the user. We thought that everything was nice and dandy, everything was great. However, we started getting 404s everywhere. It did not work, and we were scratching our heads. We thought, why? Everything sounded good on paper. The issue is CloudFront. CloudFront foiled our entire situation here. After looking at it deeply, the issue is that CloudFront caches 404s. If you look at this diagram here, you got the user, they make the initial request, they hit the page. Because Magento has the CDN turned on, it serves up CloudFront URLs. So the user then goes to CloudFront. CloudFront doesn't have that image, so it comes back to the cluster. It goes into load balancer, but it has no knowledge of the user from the previous session. So they're completely different sessions, so sticky sessions are out the door. So what happens is it hits another server in the cluster, and it grabs a 404 because the image has not synced to it yet. And the problem is it caches 404. So you make one mistake, you slip up once, and you get a 404 in there, you're penalized for usually the TTL of the time of the CloudFront setup, which is usually about 30 minutes in this case over here. So you screw up once and you're penalized for 30 minutes. It was brutal, so it did not work, and we're just trying to scratch our heads. There's got to be a way, because this is such a beautiful solution that we saw. There has to be a way to do it. And if there's only a way that you can retry the connection, so if you hit it once and it's not there, just retry again. And I'm not talking about CloudFront retrying. If there's some way, because it's hitting the load balancer, make the load balancer or something on it, try again, because it's going to hit it. It's guaranteed that at least one server in the cluster is going to have the image. So you just got to find a way to retry, right? If you get a 404, just switch it up. So we looked around, okay. This load balancer is using HA proxy. HA proxy is one of my favorite technologies out there. It's a beautiful set. It has so much functionality, but it does not have the ability to retry connections. So you can't tell it, hey, if you get a 404 from one of the backends, just go ahead and try again. There's no way to do that. It's transactional. One connection comes in, request comes in, response goes out. That's it. We took a look at Nginx. So we thought of sticking Nginx in front and using some of its logic. It has some logic that you can control into there. There was some solutions online when you asked, like, how do you retry? It didn't work out so well. You had to use some of its one of its facilities called try files. You can tell it, hey, try these multiple locations if it doesn't work out in sequence. The problem with that is it took a huge chunk of code, and you have to copy and paste that every time you add a new server. You have to tell it to chain the failovers. It was quite disgusting. So then we looked at Varnish. Varnish is also one of my favorite technologies out there. It's a fantastic caching engine. Varnish has a utility, or a not well documented feature called restart. And essentially you read the description, it'll restart a connection based on criteria. So it basically goes through the entire rule set from the start. Wherever you are, you can tell it, just go and try it again. That sounded exactly like what we wanted. And after looking at some documentation and talking to some of the devs, it only took 7 lines. It's literally this simple. You can tell it, hey, if the cache looks, if that's a URL cache and the backend response is a 404, just retry again. And you can actually configure this to retry as many times as you want using some startup options. So no matter how big your cluster is, you can tell it, just keep retrying. And we generally set the limit to twice the number of servers in the cluster, so at least it'll try twice. If there's 5 servers, it's at least going to try 10 times. With 10, at double, we can probably tune this a little bit better. It never received a 404. So basically, restart until you get a 200.
What's the time on that, though? I mean, how long is the user waiting for 10?
It is super fast.
Yeah.
You can see it hitting. It just goes right through the list. It is extremely fast.
Milliseconds.
Yeah. The user does not see it. Actually, the only time you would see that is if legitimately the image wasn't there, so you had a bad URL. Yeah. There's a little bit of time because it's retrying multiple times, but you're talking.
It doesn't often get to 10 either, right?
Exactly.
So, okay.
Yeah, it never reaches 10. But this worked out really, really well. We thought this setup over here, so we turned it on and waited to see what happened. The result is, look at that beautiful Canada Goose jacket there. It was really, really successful. It worked out well. No, not a single 404 was being served, and it is extremely scalable. The customer had the biggest Black Friday that they ever had. It was a great success. There's no performance issues, and there was zero downtime involved. In this setup over here, we actually were able to scale it up to about 35 servers. So it went from a single server, really, really big, to 35 really small, lightweight servers. And this thing could have kept going, didn't even break a sweat. That ring sync, you know, it takes a while. Maybe it takes like 2 or 3 seconds for a single image to get around, but it didn't really matter. It worked out very well, and we could have kept throwing more servers if they needed it. So it was great. We kind of had mission accomplished there. Any questions? Oh, yes.
I have 2 questions. So sure. That's a very good story about getting up a PHP-based application. So do you have any rundown of your client base? I mean, how much percentage of your clients are PHP-based? And do you have other, let's say, or C# based clients? Do you have such kind of C#? Yeah. So well, just I just need a percentage of this set.
Right.
And the second question is, this is only, spreading out the image. How do you handle that database?
Yes. So to answer your first question, so we're Linux-based, so we don't do any Windows, unfortunately. So the vast majority of our clients, I would say, it's kind of a split between Python and PHP.
So no Java?
We do have lots of Java. We do have them. If we're talking about percentages, most of them are PHP and Python, but we also do Ruby, we do Node.js. We pretty much do any kind of Linux technology out there. If we haven't seen it, let us know and we'll do the research and basically do something similar to this. So yes, that's hopefully that answers your first question. I don't know the percentages, it's been a while since I looked. The second question was the database, yes. So the database, obviously, it is a single point of failure. So number one thing is turn on all the caches. What you got to do is, you can't really do anything about the database. So actually, that's a good question. Magento has support for replicated databases. So you can set up slaves, and you can tell it to point at it. It's a piece of garbage. It does not work. Actually, we actually went to Magento support. That's why I said Magento support is not worth it, because those guys, they're useless. It does not work. What we found is when you turned it on, it would never use the read slave. Everything would hit the master, and then some magical event would trigger, and then all the reads would go to the read slave, and then nothing on the master, which is what you want. But then it just magically turns itself off and goes right back again. It was a really strange pattern, and we dug really deep into the code base, much more than we'd like, and we engaged their support, and they're like, you know, it says it's supposed to work. Did you follow this direction? Did you set this up and that up? Yes, nothing. Yes, that is exactly what happened. After they told us to send them every single configuration file and log file known to mankind, they're like, did you try turning it off and on? Yes, that's the first thing we did. It does not work. So you're kind of stuck with a single database. So hopefully using all the cache that you have enabled, the database load is actually very low. Unless you're adding new products, so they timed it so any new products were released overnight. So they added all the database entries, and then they have a cache warming script that goes around and crawls the site and make sure that everyone is already pre-rendered to kind of avoid touching the database in any which way. And the database load, once all the caches, literally every cache is on, the database load is very low. Even when they're at peak traffic, it was very low traffic. So, yes?
So, you guys, how does the pricing model work for that? Because you guys basically did contract work with this company in a sense. Was that on contract, or was that this is something that you're doing to make your service better because they're just paying a subscription?
Yeah, so we're a hosting company, so we sell servers, and everything is bundled into the price of the server, absolutely everything. So this was not on contract basis. Right. They basically came in with this problem, they paid for the servers, and we did all this setup because our goal is to make sure the sites don't go down at all. So we always say that we wake up at 3 in the morning whenever there's an issue. So we're always the first line of defense. Anytime anything happens, we're the ones getting the phone call. So we do absolutely everything in our power to make sure that the sites don't go down, because we like getting woken up at free image, like you guys know.
Of course.
So it kind of works well. It's actually a win-win scenario. So sites don't go down that often. Clients are happy. We're happy because we can sleep a lot more.
Yeah.
And you know, working in the operations world, absolutely. Yes.
So like, if you have sticky sessions, what's the need of the L-sync there? Like,
Yes, the L-sync is because you still want the images to go around the cluster. You do want it to sync. You don't necessarily have to do that because you can just let every single customer hit every single page on every server, but it's a little inefficient because every server will have to generate its own cache. So syncing it around is kind of a neat way of just making sure everyone is in sync with each other. But you're correct, you don't necessarily have to just let everyone generate their own cache. Sorry, there is one wrinkle in there because you want to make sure that the image is there because it stores it in the database. That was the issue. It tells the database, I created an image cache for this, and then it never tries to generate it again. So if it goes to server B and the image is not there, it's just going to happily serve up a 404. It's like, hey, I tried looking, it's not on the file system.
I thought that's what sticky sessions were supposed to do, right?
But then it keeps that image only on that one server ever. So a new customer comes on B, it's not going to be there, and it won't ever be there unless you sync it around. Yes?
I'm guessing this is all like dedicated servers, right?
Yes, it's virtualized. It's cloud. It's a cloud environment.
There's no shared?
It's shared. Yeah, it's dedicated virtual machine. So it's like, you know, similar to like Amazon or anything like that. Yeah, shared infrastructure. I mean, it's a cloud infrastructure, but we do dedicated infrastructures for those that have regulations, you know, like HIPAA or anything like that, where you say I need to have dedicated hardware. We do all those options.
And is the pricing model on the site?
It's on the site, yes. You can contact me or my associates in the back there, and we can definitely. It's all kind of customized situations here. It's all done in virtual machines, but everything is bundled in. Yes. Any other questions? Yes.
Do you have stats as to how many simultaneous users were hitting that server on Black Friday?
I do. I can't share them. I have been told not to share it, so I can't share it. It was a lot. It was a lot. You saw that diagram I had at the back, that spike. That wasn't theirs. I wasn't allowed to do that, but it was kind of looked like that. It was pretty big. And actually, their Christmas actually turned out to be even bigger than Black Friday. They weren't anticipating it. They thought Black Friday would be the biggest, and it was. And then this past Christmas came around, and it was even bigger. And they're attributing that to the fact that people were pissed off on Black Friday, so they came back to the deals. So it worked out well. I guess I'm out of time?
Yeah.
All right. Thank you.